Hello everyone and welcome to our latest maths lesson. We are continuing to look at division. Today we are practicing our work dividing 4-digit numbers by 1-digit numbers. So we're going to be looking at similar technique and approaches to it, but more word-based problems. My word of the day is equal, because remember when we divide, we're dividing into equal groups. And our starter to warm us up for the day is: what are the perimeter and area of a rectangle that is 56 centimeters high and 876 centimeters wide? So remember what we did yesterday for this. Pause the video, we draw a rectangle, put those lengths in. Can you figure out the lengths of the other sides? Can you figure out the perimeter and the area? So pause the video and have a go at that. Okay, let's have a look at that question. So we know that it is 56 centimeters high, 876 centimeters wide. We know that opposite and parallel lines of the rectangle are equal. So I can put these lengths in. That's 56. This must be 56. Okay, so we know to get the perimeter, it's the total length around the outside. So it's along here, along here, along here, along here. So I need to do that. To do that, I can either do 56 times 2, add 86 times 2, or 56, add 876, add 56, add 876. And because it is either multiplication or addition, it doesn't matter what order you do that in, you'll always get the same answer. So if we look at perimeter, so I'm going to do this two different ways, because I can do 56 times 2 really easily in my head, because 50 times 2 is 100, 6 times 2 is 12. If I add them together, I get 112. I think it's a little bit more difficult, but not impossible, to do 876 times 2 in my head. So what I'm going to do is I'm going to add it. So 876 plus 876. So 6 plus 6 is 12, so my 2 goes in my 1s, my 110 goes under my 10s, because I haven't finished the 10s column. 70 add 70 is 140, add 10 is 150, my 50 goes in my 10s, my 100 goes underneath my 100s. 800 add 800 is 1,600, plus 100 is 1,700. So the perimeter is 1,752 centimetres. If we're looking at area, we remember that we do width times length, or width times height. So we're going to be looking at our long multiplication. So we have 876 times 56. So we do our ones column first. So 6 times 6 is 36. 6 times 7 tens is 42 tens, plus 3 tens is 45 tens. 6 times 800 is 48 hundreds, plus 400 is 5,200. Okay, so that's my ones column done. I'm just going to put a little tick to show I've done that. And then, power of magic, I'm going to rub those out, change my pen colour. And then I'm going to do my tens column. Because I'm in the tens column, I know that I have to put my placeholder in, my 0 and the 1s, because I'm not working with 1s and I'm not going to get any more 1s. So I'm going to do 5 times 6, which is 30, put my 0 in there, my 3 there, just put my line across. 5 times 7 is 35, plus 3 is 38. 5 times 8 is 40, plus 3 is 43. Oh, I know I need to add those two numbers together, and these might get in the way. If I was doing it on paper, I'd just cross them out, but as I'm using technology, I can just rub them out. So if I add them together, 6 add nothing is 6, 5 add nothing, sorry, 5 tens add nothing is 5 tens, or 50. 200 add 800 is 1,000, so my 0 goes in the hundreds, my 1 goes underneath my thousands. 3,000 add 5,000 is 8,000, add 1,000 is 9,000. 40,000 add nothing is 40,000. So area It's 49,056 centimetres cubed. So well done if you got that. Okay, let's move on to our last warm-up questions. We have 55 divided by 5. We have something divided by 5 is 1,100, and we have 55 divided by 50 is something. So pause the video and have a go at those. Okay, 55 divided by 5 is 11, because we know that 5 times 11 is 55. Something divided by 5 is 1,100. So if we just look here, what's the difference? So if we times that by 100, we get that. Those are the same. If something on this side is 100 times bigger, something on this side needs to be 100 times bigger. So if we times 55 100, we get 5,500. The last question, if we compare the starting question again, this is 10 times bigger. However, we are dividing by something that's 10 times bigger. So we're going to get the same answer, because then we started with 10 times bigger, but we're dividing it by something that is 10 times bigger too. So the same answer. Right, let's move on to practicing our 4-digit by 1-digit division with some word problems. So Eva has 13 straws. She wants to make them into triangles. How many triangles can she make? So if you pause the video and just have a think about that, you can either just think about it and think what question you might have to answer, how you lay it out, or you can go all the way through and answer it and see if when you restart the video you get the same answer as me. So pause it now. So Eva has 13 straws altogether. How many triangles can she make? We know that triangles have 3 sides. So we're looking at how many 3-sided shapes. So the question we're really doing is 13 divided by 3. So there's different ways of doing this. You can use the bus stop method, or you can start using those straws to try and create triangles, and we'll see that we get 4 triangles with 1 straw left over. If we're doing this in bus stop method, how many 3s go into 1? 0, because you can't get a group of 3 out of 1. How many 3s go into 13? 4, because 3 times 4 is 12. 13, take away 12 is 1, so you've got 1 left over, 4, remainder 1. Okay, so very similar questions here. Tommy has 14 straws. He wants to make them into triangles. How many triangles can he make? Dora has 15 straws. She wants to make them into triangles. How many triangles can she make? And Jack has 16 straws. He wants to make them into triangles. How many triangles can he make? So have a think about those. Have a think about how you answer them. Can you use your last answer from the question on the slide before? You might want to rewind a little bit. Or do you need to do something else? So have a pause, have a think about that, and then we'll go through the questions. Okay, let's look at Tommy first. So Tommy has 14 straws. He wants to make them into triangles. How many triangles can he make? So we are once again looking at how many 3s? 14. Different approaches. You can see how many triangles you make. So here we have 4 triangles with 2 left over, or you can use the bus stop method. So how many 3s in 1? None. Because you've got one thing, you can't share it between 3 people equally. How many 3s in 14? We know that there's 4 3s. 3 times 4 is 12. And you've got 2 left over because 14, take away 12, is 2. And we've got the same here. So 4 triangles, 2 remaining. Right, the next one. So we've started off for you. So Dora's got 15 straws. She wants to make the triangles. How many triangles can she make? So you can see that we've already got the 4 here from the 12. And then we've got 3 left. So we're doing 15 divided by 3. So are we going to have 4 remainder 3 or something else? Still got 3. Triangles have 3 sides. So you can make 5 triangles. So use the straws to make them. Or how many 3's in 1? We've done this before. There are no 3's in 1 because you can't share 1 equally 3 times. How many 3's in 15? There are 5 because 5 times 3 is 15. Let's look at Jack. So we've used the 15 straws to make our 5 triangles, and then we can see straight away that we've got 1 left over. So the answer is 5, remainder 1. Okay, if we just look at these, we have 3 questions. I want you to have a look at them and see if you think they could be correct or if they're definitely incorrect. So what you need to pay attention to here is what you're dividing by and what the remainder is. Dividing by, what the remainder is, what you're dividing by, what the remainder is. So if you're dividing by 3, will you be left with a remainder of 3? If you're dividing by 4, can you be left with a remainder of 2? And if you're dividing by 5, can you be left with a remainder of 6? Let's have a look through these. So pause it if you want to just have a quick go yourself and then check. Okay, so let's look at the first one. 3,924 divided by 3, and they're saying it's 1,307, remainder 3. That is definitely incorrect, because if you're dividing by 3, you're definitely not going to have a remainder of 3, because that could be equally shared between 3 people. So it would be 1,308 if that had a remainder of 3. Let's look at the next one. 3,242 divided by 4 is 810, remainder 2. That one could be correct. We haven't worked it out, but it could be correct because, remember, the remainder has to be smaller than the divisor. The number in your remainders has to be smaller than the number you're dividing by. And that is. And let's look at the last one. So we're dividing by 5, and it's telling us it's got a remainder of 6. That is definitely incorrect, because if you have a remainder that's bigger than your divisor, a remainder bigger than the number you're dividing by, you can still make another group of 5. So if you've got 6 things, 1, 2, 3, 4, 5, 6, you can see you can still make another group of 5 out of that. So it's definitely incorrect. Okay, let's look at this. We have 5,291 divided by 4. So if we represent that with our place value counters in our place value columns, and we look at the bus stop method, so we're seeing how many groups of 4 have we got in 5. So we've got one group of 4 there, so we put 1 up the top, and we've got this one here. You cannot make that into a group of 4. So what do we need to do? We need to exchange it for 10 hundreds. So now we have 12 in the hundreds column. So how many groups of 4 can you get from 12? So we've got 4 groups of 4, because 4 times 3 is 12. Then we're looking at the tens. How many groups of 4 can you get from 9? So you can get 2 groups, because 4 times 2 is 8. And then you notice you've got the 1 10 left over, which you can't share equally between 4 groups. So you have to exchange it for 10 ones. So we've got 11 ones to play with now. So how many 4s can you get? From 11, you get 2 groups of 4. And then how many got left? 3 left. So 1,322, remainder 3. So great time to pause the video and have a go at questions 1 to 3, so you can have a little break from listening to me, and then come back and do the rest of the questions. Okay, so Tiny's back. Always in trouble when Tiny's around. He's saying that 5,627 divided by 5 is 1,126. So that is wrong. Have a think about why. Okay, the 5s times table is in a pattern. 5, 10, 15, 20, 25, 30, etc. 5,627 is a whole number, but it doesn't end in a 5 or a 0. So the answer must have a remainder. And if we look here, it tells us it doesn't have a remainder. 7 in the ones column tells us it's definitely not in the 5 times table. If it's not in the 5 times table, it will definitely have a remainder because it's not going to divide exactly by 5. Okay, there are 349 people at a wedding. They are sitting at tables in groups of 8. How many tables are needed? So just have a quick think to yourself, what is the calculation you are doing? We're going to have to do 349 people divided by 8 tables. So we're not going to use our place value columns this time, we're going straight in with bus stop. So how many 8s can you get from 3? So I've got 3 things to play with. Can I make a group of 8? Nope. So I get 0. So what do I do with my 300s? I exchange them over, so I've now got 34 10s. So how many 8s can you get in 34? You can get 4, because 4 times 8 is 32. So if we quickly go through that, we've got 34 things in groups of 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So we've got 1, 2, 3, 4 groups of 8, 2 left over. So exchange our 2 10s for 21s. Now we're seeing how many 8s you can get from 29. So if we go through our 8s, we've got 8, 16, 24, 32. 32 is too big, so it has to be 8, 16, 24, 3 lots of 8. We had 29, but we used 24. So if we do 29, take away 24, we get 5 left over. So we need 43 tables. Is that correct? No, because if you've only got 43 tables and you've got a remainder of 5, that means you've got 5 people having to stand up. So you need to put another table in there. If you end up with a remainder, you need to add an extra 1. Otherwise, you'll have people standing up, and I don't think they'll be very happy, especially if they're the ones getting married. Okay, you've worked very hard on your division this week. I'm planning on doing a problem-solving task, so more of an investigation tomorrow to give you a little bit of a break from your division before we move on to fractions next week. So thank you very much for trying really hard this week. I know there's been some difficult new methods to learn, and you've worked very hard, so thank you for that. So I will speak to you soon.